number 16, looking at the key there. Looks like our list is gonna be 3.4, 3.6, 3.9. Just start plugging these into one of your lists on your calculator. 4.6. Make sure you're doing this so you understand, because a lot of problems on the test, not a lot, but
4.8,
4.8,
4.9,
4.9,
5.1, 5.3,
4.9, I messed up.
5.1, 5.3, 5.4, 5.5, 5.7, 5.9, 6.0, and 6.1.
Things you need, and for most all the chapter, you need these things. First thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we know n is 4, or 14, sorry. N is 14, we need that. We need to know the confidence level,
99.
so 0.99. We're gonna need to know S, we're gonna get that off the calculator here in a minute. What else do we need to know? Degrees of freedom. What's our DF this time? That's pretty easy. 13.
S is 0.875.
So on there, remember to get S, you go back to stat, calculate, 1 bars. So stat, calculate 1 bars, then you put in the list number, whichever list you stuck it in. And what'd you say it came up to be?
0.875.
875, anybody else agree with that? And this time they wanted us to find the confidence interval for the variance and the standard deviation. In the formula, something like this, tell me if I'm wrong here. Instead of writing it with the alligator mouse, I'm just gonna write it like this time with the comma in that. I think it's n minus 1 in parentheses times s squared over chi squared right. And then n minus 1 s squared chi squared left, right? Correct? That's, should be a big parenthesis there. So we gotta find that. Well, we don't know the chi's yet. So what you're gonna do to find the chi's, you gotta find the areas first. To find the areas, we do 1 minus c divided by 2 and 1 plus c divided by 2. Our c this time is 0.99. I'm not sure why I put the c in there on that one. 0.005 on this one. And that means 0.995 on this one, right? Remember, those two should add up to be what? 1 whole. So you gotta find those 2 areas, then you grab your chart. Lost my chart, there it is. Make sure you're looking at the chi chart. What was our degrees of freedom? 13. Remember, you got n minus 1. And we go over to the 0.005. To find our chi squared right. 29.819. And for our chi squared left, we go to 0.995 and degrees of freedom 13.
3.565.
Everybody agree with both those? Then we just plug into here. Instead of me plugging in, just grab your calculator. If I was plugging in, what I would do is n minus one, we already did that, what was n minus one? So what I would plug in, I just plug in 13 times, what was our S this time? 0.875, square that, hit enter, and I get like 9.953 something something. Then I'm gonna divide that by the chi-squared right, so divide that by 29.18, or 29.8119. 29.819. Then I hit the wrong stupid button. Anybody get it?
Yeah, I got 0.333.
Instead of me trying to punch it in again. 0.333.
Yeah.
Then we do the same thing over here. So 13 times 0.875 squared divided by that number, 2.79. What's after a 9? 1. So this is our confidence interval for what?
It falls in between that 99% of it.
Yeah, that's true, but what's it for? This is for the variance, right? That's for the variance. Then they still wanted the confidence interval for what?
Oh my, then you gotta square root it.
You gotta take the square root of each of those. So once you have those two numbers, second square root, put in the first number. What'd you come up with?
0.577.
Anybody agree with Dalton? And what's the square root of this one?
1.67.
1.67. And this is the confidence interval for what? Instead of variance or sigma squared, this is just the standard deviation, which is your sigma. So those are your two answers.
Well, would you want us to put both answers on the test or just for standard?
It'll tell you. I think one of the problems on the test says find both intervals. So just make sure you read the problem carefully. I mean, it's not like it's a real long test because, you know, if one problem takes this much, there's only 15 problems or so on the test. Other questions? This will make Sean happy since I've been messing with him all the time because he's not been doing his homework. Because I didn't do this problem.
Sean.
He was sleeping. He wasn't paying attention. Website costs as part of a survey. At least I don't think I did this one. Maybe I did. As part of a survey, you ask a random sample of business owners. Oh no, this is one. When I was making up the test, that's where I seen one like this. How much they would be willing to pay for a website for their company. The results are shown in the figure using 90% confidence, level of confidence. So our C we know is 0.90. Looking at that picture there, what else do they tell us? They tell us in. And this time, it was nice of them to also tell us what? Don't they tell us S?
Oh, yeah, 36,000.
36,000?
Yeah.
Whoa.
3,600. Oh, crap, 3,600. Whoa.
So we know C, we know N, we know S. What else do we need to find?
Freedom.
Degrees of freedom, what's that give us? 29. And I just erased the formula. See, in the formula we needed N, we needed S, and we need our chi's, right? So next thing we gotta find is our chi's. So we're gonna do our area. 1 minus 0.90 divided by 2, and 1 minus, or I'm sorry, 1 plus 0.90 divided by 2. What's this one give us? 0.05. That means this one probably gives us 0.95, right? Now to find our chi's, chi squared right and chi squared left, those are our critical values. Oops, that's supposed to be an L. We use the chart, look up 0.05 and our degrees of freedom, which is 29. What's that give us? 42.557. Ignore that stray little stupid thing going up through there. And for the left, we use 0.95 and 29.
17.708.
Wait,
How'd you find that?
off the chart.
You just.
This is from the chart. Use the degrees of freedom and your two areas here. Match them up on the chi chart. Don't forget to make sure you have your charts marked. We got the T chart, we got the standard chart. That's the one we use for the Z-scores. And then you have the chi chart. Now once we have all that, we're going to use our formula again. N minus 1 times S squared divided by chi squared right. That's our low limit. And our high limit is N minus 1 times S squared divided by chi squared left. So that I don't have to write all this down. Remember, our first one is our variance that we're finding. Somebody plug all that in. What do you put in place of N? 30, and 30 minus 1. You could just punch 29 into your calculator. 29 times 3600 squared divided by the 42.557. What you come up with? Might be sort of a big number. 883,149. 449. So 0.6, we'll say, we'll stop there. Pretty big number. Do the same thing on the other side. 29 times 3600 squared divided by 17.708. This one's gonna be
21,224,305.
I'm just gonna leave off the 0.4. Let's see, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 6, 7, 8, okay. Now, I looked at this to make sure, what should be true about this number in relationship to this number? What should be true about the second number that Dalton gave? Should be bigger. So I just wanted to make sure that it was bigger, make sure we didn't make a mistake somewhere. That's one of our answers. How do we find the square? Take the square root. So take the square root of this number. Hopefully Carson's watching closely if he didn't get the hint. Back when I said I was working on this problem, oh, it was a different problem. Because where was I working on it at? Yeah, that's true, but what did it come off of? It was on the test.
So, 2,971.
2,971.
You want me to round this up?
Yeah, just give me,
1.8.
so 72, we'll say, close enough. Square root of the other one,
4607. You're rounding.
4607. Now, we could have probably went out, we probably wouldn't want to go out one decimal place. We probably want to go out two, because what did this problem deal with?
Good question. The survey, you asked for business owners. How's it cash? Pay for websites.
It's money, right? Cost of a website. So either we round it off to about the nearest dollar, don't go out one place because that doesn't make any sense in money. You maybe go out two because then that makes sense. So we're saying that the standard deviation, the amount that could change for these web costs is anywhere from about $3,000 to about $4,600. So we give a business, hey, this website we're gonna build for you is gonna cost $7,000, within $3,000 to $4,600, one way or the other. So again, variance, standard deviation, those are the, and stuff like this, I'm not really high on using standard deviation for something like that because it doesn't make as much sense for an interval. Standard deviation makes more sense if you own a business and you're seeing back to our doozles where we were making sure that they were all within a certain range. We didn't want it to be farther off than that because it had to fit into something. Other questions? Riley can handle all that. Pretty easy stuff.
Oh, yeah. Ready for the test?
Just take it day, I got it.
Might as well.
Alright. Go ahead and start copying this down. This is what's gonna be on the test. And I separated these, all right? So we got like 4 slides because in this chapter there were how many sections? 4 sections. So this is like section 6.1. Section 6.1 dealt with mean for large samples, confidence intervals of the mean for a large sample. I tried to make it sort of short, so I didn't put everything up here, but tried to make it the stuff that's probably the most meaningful from each section.
When's Grant come back?
Hopefully. Probably the day of the test, because they'll probably be mad at me if you'll have to take it. I wonder if you, when you freeze that, does it keep recording what's out here, or does it record what's on my computer?
Play out here. Play the same. Yeah. Out here, the time just changed.
Alright, so confidence intervals, way back at the start, confidence intervals for mean with large samples. Remember, a large sample is anything that's what?
30 or bigger.
Huh, huh, huh.
30 or more. 30 or greater. Now with this one, you can also use this stuff, and this is your Z critical values. You can also, or if you're looking at your charts, this is the normal chart, the normal distribution chart. So make sure you got all three of those charts. You got that normal distribution chart. You can also use this if you're 30 or more, or if you know the standard deviation for the population. Those are the times when you use that, the first thing that we did. What's E stand for? Margin of error, good. Margin of error. Remember your E, what you do with it. To get your low end of your interval, you subtract the E from the X bar. To get your high end, you add E to the X bar. Guarantee there's a problem on the test that's going to give you X bar, or maybe it'll just give you, I don't know, probably both of them. It might just give you something like this. 3.5, 8.9. And it wants you to find X bar and E. How can you find X bar there? Add them up, divide by 2. Alright? How can you find E? Minus them, divide by 2, or Jesse said when he was doing it, once he got X bar, he just took one of them minus X bar, and that gives you
It doesn't matter.
there. Well, it does sorta, because if we take this one minus X bar, you're gonna get a positive number. If we took this one minus X bar, you're gonna get a negative number.
So,
And it's gotta be the positive.
alright, so if you add them together, it gives you,
Add them together, divide by 2, it gives you X bar. This is like if it's backwards, right? If we already know the interval, you add them together, divide by 2, it gives you X bar, it gives you what's in the middle. Remember when we first started this, we were like this. So we'd say this was 3.5,
so you knock them together.
this was 8.9. X bar would be right in the middle here. Well, to find that middle, we just average them, add and divide. And then
if
to,
the margin of error, we subtract them by 2.
you could, yep. The margin of error is that distance from there to there. The distance from X bar to this number, or the distance from X bar to the low limit. However you want to find it. On the calculator, this is the one you use the Z interval on. Might be helpful now, somebody grab their calculator, and what things do we have to know to use the Z interval? And we'll write them down right here in your notes. Must know.
You gotta know the standard, or,
Standard deviation.
yeah.
So S,
X bar,
X bar,
and
N,
confidence.
and C. So you got
Deviation's a little,
it's the sigma.
yeah.
Alright, so this should be the sigma here. Remember, are you gonna know sigma most of the time? No, so when we were doing this, we stuck what in its place? We stuck the S in. If you know the S, then you stick it in place of the sigma. What's sigma stand for?
Standard deviation.
Standard deviation of
The mean, or sample, or population.
population. S stands for standard deviation of the sample. Either one of those. To find the minimum sample size, you gotta know your critical Z values, or your critical Z value, your standard deviation. And again, for the standard deviation, in place of this, we could stick in S right there. and you gotta know your margin of error. Remember, this is gonna give you an answer, and your answer might look something like this. 1,326.825. That shouldn't be your answer. What should be your answer there? When you're trying to find the minimum sample size.
You're right.
You round it, and you always round it up. So if we're gonna survey people here, how many people are we gonna need to survey to make this work out? 1,327, at least 1,327 is the way we would write that. We need at least 1,327 in our sample size. Remember to find your critical values. You're on the normal chart. I can't remember for sure on the test, but you might want to circle this little thing right here at the bottom of this normal chart, because that's probably where you're going to get most of them. Most of the time, our confidence intervals are 80, 90, 95, and 99. If it's not that, then we have to go through and find them the long way. I'm trying to think, maybe we better do that. I didn't put that on here. Let me erase some of this. Everybody got everything written down off that they want?
Oh, yeah.
Pen doesn't work. So let's look back here in the book and see this formula. How do we find B, or some of you could help me if you know how to do it without me looking it up. How do you find the critical value for Z? What'd you say? Critical value for Z.
You just go through my brain.
Like find the Z-score.
Yeah, sort of. Not look it up on the chart though. We need other stuff before we look it up on the chart.
It says Z equals X plus 10%.
So if, what we're saying is, we wanna know, remember you got your normal curve here? We wanna know this value and that value. How do we find those values? If we're given, if our confidence levels are 80, 90, 95, or 99, then we just use those right there, that little chart, because it gives it to us pretty easy. And most of the time, those are the ones that we'll be using. But if we're trying to find it out longhand, then what we need to do is what we were just doing to find the area on that other one. 1 minus C divided by 2. So let's make up a strange one and see if we can figure it out. This one that's not 80, 90, or 95, or 99.
C equals 70.
So we plug in 70 here. Let's make sure we're doing this right. 1 minus 0.70 divided by 2. What is 1 minus 0.70 divided by 2? Now, this is your area, and then instead of using the chart, I think what we did is we used our calculator. All right? On your calculator, this is where we do the inverse norm. So if we go on inverse norm, second vars, we go down to inverse norm, second vars, second, not 2, second, then vars, inverse norm, you hit enter, and it asks you for the area, the mu, and the sigma. Mu is always going to be 0, sigma is going to be 1, and we just put in that 0.15. Paste and enter, and we end up with our critical value is negative 1.04. Well, I really don't care about the negative. I just want the 1.04. So on our chart here, what's this number right here that goes along with this critical value? 1.04. What's the one that goes along with this one? Negative 1.04. So we do, to find the z-score, if it's some crazy confidence level, if it's not one of these four right here, 80, 90, 95, or 99, then we do this. 1, and I shouldn't have put this, that's not equal to z, our z, this is our area right here. 1 minus c divided by 2. I come up with that number, that's right here, that's our area. And then I do second bars inverse norm, because I'm looking for this area. I'm looking for what z-score goes with that area right there. What's that cutoff? So you do second bars inverse norm and you just punch in the area that you came up with. So let's do another one. Give me another crazy confidence interval. Give me some other confidence interval. Or confidence level, sorry. 50. 0.50. So what we're going to do to find the area, we do 1 minus 0.50 divided by 2. And what we're looking at, again, we're on this normal curve. We're looking at this area. We're actually dividing it by 2 because there's 2 areas here. One on that side, one on this side. And we're looking for that z-score right there that cuts that much off. What's this give you? 0.25. That's our area. Now what we do is we hit second on our calculator, second bars, and we go to inverse norm. Remember the inverse norm we did last chapter or 2 chapters ago? That's where you're using the chart but using it backwards. You have the area and you're finding the z-score instead of knowing the z-score and finding the area. Negative 0.67. So that means this value right here is negative 0.67. What's this value right here? 0.67.
What do you plug in once you put inverse norm?
Just the area. Just this right here.
0.25.
Just that.
Standard deviation.
If you have the old calculator, all you got to do is put in the area. Put in that 0.25. If you have the new calculators, it asks for standard deviation and
The U?
mute.
Yeah, standard deviation
Second bars.
and 0 and 1.
And sigma. Oh, that is sigma. Yeah, so mu and standard deviation. Mean and standard deviation. Thank you, you're right, Dalton. I should never doubted you should have. So it asks you for those two. Now, normally, if we're on the normal curve, this is going to be 0 and our standard deviation is going to be 1, so we don't even mess with those. Remember last chapter when we were putting in raw scores and our mean was 7,250 and our standard deviation might have been 75 or something. Then we had to punch those in. Now, again, when you're looking at these, the only one that you really need so that you can do this right here is the positive one. So your calculator is going to give you the negative one, and you just have to change it to what? Positive. Instead of negative 0.67, when we come down here and we're looking for how many needs to be in the sample size, we just put in the positive number. So you put in 0.67 there. Then you put in your sigma, you put in your margin of error, multiply, divide, then square that answer, gives you the minimum. Same thing up here, if you're looking for this, you're going to put that 0.67 in right there.
That's to find the ZC or whatever.
That's all that we just did was to find ZC, your critical value for the ZC. Now, a lot of times, if they're just asking you to do the confidence interval, do you even need to find the ZC? No, because all you're gonna do is use your calculator, and what things did we say you needed for Z interval? You needed like N, C, what else did you need?
Standard deviation.
Standard deviation, seems like there was one more thing.
X bar.
X bar. So we know those four things. If we're just finding the interval, then you plug those into your calculator, it'll tell you the low and it'll tell you the high. Next one, this is section 6.2. Section 6.2, which was intervals for the mean, but for small samples. And remember, this is using the T-chart. This is using the T-chart. When you're doing the small samples, it's using the T-chart. What are small samples again?
30 and below.
Less than 30. Less than 30.
Oh, so not 30?
Yeah, 30 is actually one, and 30 is right on the border, because you notice your T-chart here only goes up to 29.
Yeah.
So could you use 30? Yeah, because the DF is the number minus 1, so it goes up to 30. So 30, you could use either one. So if I put 30 as one of the problems on the test and use the T-chart, I'll have to know that answer. Or if you use the Z-chart, the normal, I'll have to know that answer.
Hopefully there won't be one that's 30. Now you're gonna make one with 30, probably.
Just for you, Jesse. I got a special test today. Nick, don't be telling people I've been messing with my phone, trying to get it to shut down when the battery was so dead that it wouldn't do anything. But the volume's up real loud because my wife was on the phone last night.
It's a nice ringtone.
Now I'm trying to get it where the volume's in, so it didn't go off throughout the day.
Time to upgrade to an iPhone.
Do what?
Time to upgrade to an iPhone.
You don't care.
7 plus.
I figured you'd have some rocks on as your ringtone.
That means I'd have to mess with that phone. I don't wanna mess with that. I'm gonna keep it turned on most of the time. That goes back to what we were talking about at the start of class. Who do I wanna talk to? How do you find DF?
N minus 1.
N minus 1. Every time when you're using the T-charts, and for the last section, you gotta find that DF right off the bat. On the calculator, to use the T interval. Somebody help me out and look it up on your calculator. Use the T interval. What things do we need to know?
X bar
X bar.
is
C. So basically, same stuff as the last one, right? What's the only thing that changed there?
S.
Okay, and it changed from sigma, which are the same. Most of the time, we won't know sigma for the big samples either, so we'll have to use S for sigma. What's E stand for again? Margin of error. Margin of error. To find our interval, we take X bar minus the margin of error, comma, X bar plus the margin of error.
What's the TC?
TC is your critical value again, just like the ZC on the last one. The TC is a little easier to find because you don't have to mess with the area. Give me a confidence interval,
90.
or a confidence level, 90. So we do 0.90, that's our TC, give me an N.
60. Oh, 20.
If N is 20, what's our DF?
19.
And all you do is use those two, go to the T chart. Take that back. Let me think for a second. This one's a little easier to find. Shouldn't have doubted myself. A little easier to find. You use that 0.90 and the degrees of freedom. Go to your T chart. Go down to 19 on your degrees of freedom and over to the column that's 0.90. And we come up with 1.729. That's our TC. That's our critical value. And then if we need to find our margin of error, we stick that in there, S on top, square root of N on bottom. Did I confuse everybody by that, Nick? You can handle that. So that one's easier because it's just degrees of freedom and the critical value. You don't have to do the half or any of that stuff. Subtract from one, find the area. Again, I think for this section, for section 6.2, we used the calculators a whole bunch, didn't we? It was mostly just all calculator work. Section 6.3. Section 6.3 was intervals for the proportions or the probability. These are the percentages. So the P hat and the Q hat and all that stuff. Anybody have any idea why my phone wouldn't charge when it's hooked up to the computer? Is there a reason? It doesn't seem to want to charge on the computer anymore.
Maybe the plugins messed up.
It's working out here when
It's like different amps.
it's the same plug-in, it's just because I'm using the little box and just unhooking it. One for the computer, one for a outlet.
I don't know.
There's less amps out of the computer.
But it doesn't charge it at all anymore. I mean,
It used to.
I understood it used to, it used to charge slow, but now it,
Really?
yeah, because I had it plugged in all day yesterday on the computer and that's why it was dead this morning. Because I didn't even look at it yesterday, just.
My mom like slept in my lunch. My dad would kick the door down.
Yeah, my dad will tell me to stand me straight up out of the dead sleep and I'll fall. Then he'll stand me up again until I'm awake. It makes me mad.
That makes him happy, Fred laughs the whole time.
Yeah, he laughs because I'm all dazed and I don't know what's going on.
How come on the last one, on section 6.2, how come there wasn't a formula to find the minimum sample size?
What's the minimum sample? It's 30 below.
It was 30 and below, you don't want a minimum, you already got very small
Yeah.
sample anyway. You're not gonna give Dalton enough credit, he's pretty intelligent.
No, he's not.
Oh, I forgot something on this thing. Cause we used the calculator on this, right? What do we put in on the calculator? Couldn't we use calculator to find the confidence interval for the proportion? Anybody remember that?
What'd you say?
What was the calculator setup that you had to use? If you don't remember it, we'll just leave it off and we can do this one out longhand on the test.
What was,
Prop Z interval?
Was it, what is it, one prop
Yeah, it's one prop.
Z interval? So on the calculator, use the one prop Z interval to come up with this. What do we need on that?
It's just X. And, let's see, I don't know about the new ones, but.
I think that's all it is on, I think that one's the same number. So one prop Z interval and all you need is your X. Remember, it's not X bar, it's X. X stands for how many people said yes or the successes in the, whatever you're doing. So X stands for the successes, N stands for the total number of the sample, C is your confidence level. If I gave you something like this, told you X was 20, N was 152. Got to be able to find P hat. P hat, remember, is your probability. How would we find P hat? 20 divided by 152. Take your calculator and divide it. What's that come out to be? 132. Now that's our P hat. How do we find Q hat?
1 minus P.
1 minus whatever that was, right? 1.32. And that gives us our Q hat. Our confidence interval, or I'm sorry, our Z, our critical value. Remember, most of the time you're using that little chart. Every one of these was 80, 90, 95, or 99. It was one of those four. So you use that little chart right here again on the normal distribution. To find your interval, P hat minus your margin of error, P hat plus your margin of error. Same idea. Again, if you use the calculator, you use one prop Z interval. Seems like I'm missing something on this. What if I told you this? P hat is 25%. So we know that the probability of whatever it is we want to occur is 25%. And I told you N was 210. So our sample size was 210. And we were trying to find the interval. Well, what three things do we need to know for the interval? X, N, and C, right? Well, we know N and C, but we don't know X. How could we go about finding X from this information that we're given? P hat times N. So to find X, you might want to write that down somewhere. To find X, it's P hat times N. If you're looking for X, if you're looking for the number of people who said yes or made it a success, it's P hat times N. That way you can plug it into the calculator. Several problems that we did in that section that you had to find your X. They didn't tell you X.
So P hat divided by X would be.
Yep. So N would equal P hat divided by X. Is that right? No, it's not. Here I just,
That's why I asked you.
here I just gave you a compliment. How about x divided by p hat? Don't add upside down.
Should've done that. How much more notes?
One more slide.
Oh my.
The last one. Remember this 6-4, this is what we just got done doing. Main thing on this one, what can't you use on this one? Or well, you can use it, but what? No calculator. There's no T interval or Z interval to just get it. You gotta actually do some of the math out. These are the this is the formula that's key on this one. What 3 things do we need to know on this formula? N, so we must know N,
S and X R, or X, whatever that is.
the chi-squared right and the chi-squared left, right?
Yeah.
Correct? You gotta know those things. Probably the hardest thing is finding the chi-squared right and the chi-squared left. Remember, that's where what we just got done doing, that's finding the areas. For areas, remember when you find those areas, to find the areas, you do 1 minus c divided by 2 and 1 plus c divided by 2. That gives you the 2 areas, and then once you know the 2 areas, you use the chi chart along with your df to find the 2 critical values, the 2 chi's. Handle all that, Mr. Miller. Pretty easy stuff.
It's the easiest thing we've done all year.
What's this? And again, if you write yours on your test, you'll probably write them with the parentheses, low limit here, high limit here. That's fine. I wrote this one out with the alligator mouse, probably because that's what they had on the slide, and I just copied and pasted it, so I didn't have to do all that. Probably why that was.
What chart is it?
It's for this one, it's the chi chart. The chi chart. So make sure you use the chi chart on this one. This gives you the interval for what? Number 20 here gives you the interval for what? The variance. This is variance. And then 21, what do you do in 21? Just take the what? Square root of both sides, take the square root of both sides, and that gives you the interval for standard deviation. Those are the ones we just got done doing off of. We did a couple of them today. Off of page 341. Probably only got a few more grades before the end of 9 weeks. This is one of them. So this review packet will be collected next time. Test. We may take another symbols quiz or test here in the next few days, probably next week at some point. And maybe a homework or two. So before the end of 9 weeks, not a whole lot. We got about 6 minutes. Anybody want to see me work anything off that review, or are you tired of hearing me talk?
No, we're out today.
Yeah, number 9. Number 9. Number 9. Number 9 says find P hat and Q hat given the following situation. In a survey of 5,243 parents, so what's that 5,243? What letter is that? N. 5,243, that's our N, that's our total sample, right? 2001 think that governments should subsidize the cost of computers for lower income families. What's that 2001?
X.
That's your X. Now remember, that's not X bar, that's just X. Those are the successes. How do we find P hat?
X divided by N.
So we take 2001 divided by 5,243. Somebody help me out. 381. That's 0.381. That's not a extra one there on that stupid thing. How do I find Q hat then?
Minus.
1 minus that. 1 minus 0.381. What's that give us? That's all you had to do on those two. Got time probably for another one if you want to see another one. Six. Find the critical value TC for, and they give us a confidence interval there. Let's see, C is 0.99. Come on, you stupid thing. 0.99 and N is 17. What's that N being 17 tell us? Alright, so we're going to use the smaller ones, right? So instead of using the normal chart, the Z chart, we're going to use the T chart. So DF is 16, and on that T chart, you just use those two. You don't have to do the area and all that. So look up on the T chart, 0.99 and a DF of 16. 2 point what? 921. That's our critical value. 2.921. That one took all of 1 minute. Give me another one. Thought you guys would pick a hard one or something.
13.
But then 2 easy ones. 13. Problem 13, we may not get this one completed. As part of a survey, you asked 30 business owners, what's that 30? That's our N. Should write this stuff down as you go. You're paying for a website using a confidence interval, so that's our C, 0.99. Sample standard deviation, so is 1800, so that's what? S. 1800, good. To construct a confidence interval for variance and standard deviation. So you grab your calculator and you punch this in, right? No, not for this. We have to use the formula. We have to use this formula. N minus 1 times S squared over, what was it over? Chi squared R, right? And then the other one is N minus 1 S squared over chi squared L. Well, we know N and we know S, but what two things don't we know?
X2R and X2.
The chi's, right? To do that, we got to do the areas. 1 minus, this time it's 0.99 divided by 2, and 1 plus 0.99 divided by 2. That's 0.005, isn't it? This is 0.995, is that right? then where do we go from there? Where do we go from here? Use the chart, what else do we need?
After you do King
We're doing the chi, right?
Yeah.
So we need the degrees of freedom. What are the degrees of freedom?
29.
29. Use that, look up on the chart, you can find those two, then you can plug in and find your limit. How you gonna change it to, or that's gonna be your first interval. Your second interval, what you gotta do to each number? Square root, right?
We'll figure it out. I don't know about you. Dalton thinks he's a genius now, that you told him that he was. Why
I didn't say it was a genius, I said very intelligent sometimes. I don't know, Dalton, I guess we'll see when I give your test back, we'll compare yours to Jesse's and see if he's got anything else to say.
Hey, I'm not saying I'm a genius.
But you can't be making fun of Dalton if.
I can though, but I'm still.
You're still recording.
Alright, thank you. See ya.
Have a good day.